Hello everyone. Today I am going to discuss compiler design. What is meant by a compiler? A compiler is a specialized program that translates source code written in a high-level programming language into machine code or intermediate form. Why do we need a translator? Computers understand only low-level machine language while human uses high-level languages. Therefore, we need a translator to convert high-level language into low-level language. The process of compilation involves several distinct phases, each with a specific purpose. These phases can be broadly classified into front-end and back-end processes. The main phases of a compiler include the front-end phases, that is, lexical analysis called scanning, syntax analysis called parsing, and semantic analysis, and the back-end phases are intermediate code generation, code optimization, and target code generation. Next, we will provide a detailed explanation of each phase, starting with lexical analysis called scanning. The objective of this phase is to convert the sequence of characters in the source code into a sequence of tokens. This is achieved by reading the source code character by character and grouping them into meaningful sequences called tokens. The example for tokens are keywords, operators, identifiers, literals. The output of this phase is tokens, which are a building block of a programming language syntax. Second phase is syntax analysis called parsing. The main objective of this phase is to analyze the tokens to ensure they follow the grammatical structure of the programming language. This is achieved by organizing tokens into syntax tree, also known as parse tree or abstract syntax tree, that represents the grammatical structure of the source code. The output of this phase is abstract syntax tree, which reflects the hierarchical syntactic structure of the source code. The third phase is semantic analysis. The objective of this phase is to ensure that the syntax tree conforms to the semantic rules of the programming language. The syntax analyzer checks for the semantic errors. The semantic analyzer checks for semantic errors and annotates the syntax abstract syntax tree, which type information and other semantic data. The output of this phase is an annotated abstract syntax tree with semantic information. The fourth phase is intermediate code generation. The objective of this phase is to translate the annotated abstract syntax tree into an intermediate representation that is easier to optimize and translate into machine code. During this phase, the compiler generates intermediate code that is independent of both source and target languages. This intermediate code often takes the form of tree address code or other abstract representations. The output of this phase is the intermediate representation. The fifth phase is code optimization. The objective of this phase is to improve the intermediate code to make it more efficient without altering its semantics. During this phase, the optimizer performs various code transformations to enhance performance, such as eliminating redundant code, looping, optimizing loops, and improving data flows. The output of this phase is an optimized intermediate representation. The final phase is target code generation. The objective here is to translate the optimized intermediate code into the target machine code. During this phase, the code generator maps the intermediate representation to the instruction set of the target machine, producing assembly or machine code. The final output of this phase is the target machine code, presented as either assembly or binary code. Here is a concise summary of the compiler design phases. Lexical analysis called scanning, which tokenizes the source code. Syntax analysis or parsing, construct the syntax tree. Semantic analysis checks for semantic errors, annotates the syntax tree or parse tree. Intermediate code generation phase will produce an intermediate representation. Code optimization phase refines intermediate code for efficiency, and the final phase, target code generation, generates assembly code or machine code. Thank you.